This is an issue we have been covering for a very long time that is getting more and more press from more and more scientists. But just to refresh your memory about immune enhancement, this is a video we played all the way back in April, I believe April 9th. This is Dr. Peter Hotez, one of the scientists that attempted to make or has been attempting to make a coronavirus vaccine for a very long time. Get ready, grab your notebooks. We're going to get in the weeds on this one. If you care to know, the high wire is where you're going to find out. This is Dr. Peter Hotez.
One of the things that we're not hearing a lot about is the unique potential safety problem of coronavirus vaccines. This was first found in the early 1960s with the respiratory syncytial virus vaccines. Some of those kids who got the vaccine actually did worse, and I believe there were 2 deaths in the consequence of that study. Because what happens with certain types of respiratory virus vaccines, you get immunized, and then when you get actually exposed to the virus, you get this kind of paradoxical immune enhancement phenomenon. And we don't entirely understand the basis of it, but we recognize that it's a real problem for certain respiratory virus vaccines. That killed the RSV program for decades. Now the Gates Foundation is taking it up again. But when we started developing coronavirus vaccines, and our colleagues, we noticed in laboratory animals that they started to show some of the same immune pathology that resembled what had happened 50 years earlier. So we said, oh my God, this is going to be problematic.
Oh my God, this is going to be problematic. That was what Peter Hotez was saying when he was attempting to make a coronavirus vaccine. Now, that is a video I played all the way back in April 9th on the High Wire, but I want to be perfectly clear. We have been discussing this immune enhancement problem that Dr. Peter Hotez was discussing in front of the Congress since all the way back in February. In fact, it was one of the first things we were really concerned about when we started watching people drop over in the streets in China. I won't go all the way back that far, but I want to talk about this discussion. There were studies that were done, trials that were done when there was a SARS coronavirus back in the early 2000s, what Peter Hotez was talking about. Multiple drug companies set out to make a SARS coronavirus vaccine. They all had the same problem. Let me take you through one of these studies. This is the immunization with SARS coronavirus vaccines leads to pulmonary immunopathology on challenge with the SARS virus. It goes on to say, talks about necrotizing vasculitis was prominent in medium and large blood vessels. But let's go down to the dark letters. All mice exhibited histopathologic changes in lungs 2 days after challenge, meaning 2 days after they were actually put in contact with the virus, including all animals vaccinated or given live virus influenza vaccine or PBS, suggesting infection occurred in all. The histopathology seen in animals given one of the SARS-CoV vaccines was uniformly a Th2-type immunopathology with prominent eosinophil infiltration confirmed with special eosinophil strains. The pathologic changes seen in all control groups lacked the eosinophil prominence. It went on. This is another article conclusion. Same study. Here's the conclusion. These SARS-CoV vaccines all induced antibody and protection against infection with SARS-CoV. However, challenge of mice given any of the vaccines led to occurrence of Th2-type immunopathology, suggesting hypersensitivity to SARS-CoV components was induced. Caution in proceeding to application of a SARS-CoV vaccine in humans is indicated. Caution, don't move forward with human trials. Very simply put, these animals developed antibodies. The vaccine didn't seem to be hurting them, so it seemed safe. But then when they were challenged with the actual virus, injected with the actual coronavirus, something happened. The antibodies didn't seem to protect and neutralize and kill off the virus. In fact, it seemed to help the virus penetrate the body and cause major problems. All these studies had different issues, but talked about vasculitis, talked about upper respiratory illnesses, organ failures. Very, very catastrophic results. Well, at the end of that, it said, you know, be careful moving forward with human trials. Well, guess what? We are now in the human trials. We're moving into third phase trials. We are deep into this. And now, suddenly, a lot of scientists are weighing in saying, have we figured out this problem yet? Do we even know what this problem is? There you are, coronavirus vaccine developers wary of errant antibodies. Oh, well, you know, it's about time, since here at the High Wire, we've been worried about it all the way since back at least in February. But to really try to drill down on what's happening here and get an understanding of what we're talking about, I want to bring in somebody that really understands antibodies, a doctor that has been treating autoimmune disease and things that deal directly with problems with vaccines. Of course, I'm talking about Dr. Nguyen Schwander, who joins me right now. Dr. New, we've alluded to this, we've talked about it, we've looked at old studies, but this is really starting to become a conversation amongst many different scientists. In fact, some are gunning for each other and gunning for each other's vaccines on this issue. But is there a way, and I know every time I talk about this, I feel like I'm barely hanging on to an understanding. Is there a way to sort of simply lay out what we're talking about when we talk about antibody-dependent enhancement or antibody immune enhancement, these different things that are being discussed right now?
Yeah, it starts with just understanding what antibodies do. So, you know, there isn't just one antibody, there's a number of different types. So here we have an illustration of what's called a binding antibody. So a binding antibody is going to bind the virus, but not enough to destroy it. What we're looking for are neutralizing antibodies. They're going to bind that virus, poof, the virus is gone. It's only the neutralizing antibodies that are going to eliminate the virus from the body. It's when you have those binding antibodies that aren't effective at eliminating the virus that you start getting into trouble. And that has a lot to do with how the immune system recognizes that in terms of, is it going to get rid of it or is it just going to react to it?
Got it. So there's a difference. There's different kinds of antibodies. One are binding, the other are neutralizing. Neutralizing, kill it. Binding, just kind of sit around with it, so not as effective.
Right, and
Okay.
and you know, we have a good illustration of this in terms of how those binding antibodies can create what you're talking about with the antibody-dependent enhancement. So with the neutralizing antibodies, they're going to bind the virus. It's going to be recognized by the macrophage. Poof, it's all gone. With the binding antibodies, doesn't quite bind the virus correctly, or maybe the virus has changed, but these are not going to be recognized by the macrophage. But the antibodies have that tail on them. It's called FC, and these immune cells have a receptor for that FC, and they'll bind the antibody virus complex, take it into the cell. So now you have virus inside immune cells, and those immune cells start making copies of the virus. So they're actually virus factories at this point, and they'll replicate the virus. In addition, they will create these inflammatory cytokines. We all know about the cytokine storm. This may be part of what's contributing to it, and that creates a real mess. And remember, these antibodies are, you know, they can happen from natural infection. So it's one of the thoughts of, why do some people have a real problem with this infection and other people it's a cakewalk? It's not a problem at all. Plus, it can also happen with a vaccine, and that's what you're talking about with those original SARS-1 trials on animals, where you had these antibodies. They weren't effective at clearing the virus, and they created so much more pathology for the animal.
So, and there's a lot of discussion now about, you know, if there's not a robust antibody response, you know, if we don't create enough antibodies, and I suppose we don't get enough of the neutralizing antibodies, if it's a weak vaccine, then we could really be in trouble of creating this antibody immune enhancement, right? And so I'm leery as soon as I hear the FDA is already reducing their confidence and saying, hey, if it's 50% effective, or I think about those old flu shots when they were, you know, some are 10% effective, we got to wonder, is that a low antibody production? If the vaccine isn't really working well, are we setting ourselves up for these cytokine storms and issues like that?
Let's take the worst hypothetical outcome, where you have a vaccine that's completely ineffective. It'll generate antibodies, but they're going to be strictly binding antibodies. So if you have that type of situation, you're going to have lots of antibody-dependent enhancement if that person gets exposed to the virus in the future. But all these vaccines will create binding and neutralizing antibodies, and it's a matter of how much of each one. And that's
Okay.
what makes this interesting when you start looking at some of the animal trials or the human trials. You know, we'll talk a little bit also about cellular immunity because, you know, I was on the show a few weeks ago talking about Th1 and Th2
Right.
responses, and that's important as well. But the important thing with a vaccine is you want to have a robust neutralizing antibody response, and you want to have that relatively quick. You don't want a vaccine that's going to create all these binding antibodies and then maybe add some neutralizing antibodies on afterwards, because that potentially could create this window where you've made the person more susceptible should they be exposed to the virus. And that's the last thing you want to do with a vaccine.
Okay, great. Let me take you then into some of these studies that we are reading about right now. This is the New England Journal of Medicine. This is the evaluation of the mRNA 1273 vaccine against SARS-CoV-2 in non-human primates. Now, this is coming from the Moderna vaccine, which has got the NIH patents in it. It's the baby for Tony Fauci. I want to read through some of these things and then have you explain what we're talking about here. So in this, they're looking at primates, and this is what they say. Seroconversion was rapid for binding antibodies occurring within 2 weeks after the first vaccination. But pseudovirus neutralizing activity was low before the second vaccination, which supports the need for a 2-dose vaccination schedule. Now, is this what you're saying? What they're talking about is the first shot really just created binding antibodies, which could lead to this immune enhancement problem, and it wasn't until after the second shot that we got the neutralizing antibodies? Is that what they're talking about there?
Yeah, that's what that looks like, that you're creating a lot of antibodies, so lots of antibody production, but they're primarily binding antibodies initially, and you need that second vaccine to get that boost. So, I mean, this graph really shows that. So the binding antibodies are there right away. It's the neutralizing antibodies. You really don't see a big jump until you get that second shot. And without that, you don't have protection against the virus. So if you are exposed in that initial segment where you get the shot, you develop the binding antibodies within a couple of weeks, you don't get another shot for a couple more weeks, you have that window where potentially you could have antibody-dependent enhancement from the vaccine. And again, you know, everything would have to come together at the right time, but that would create that issue until that second shot a week or 2 weeks later. Now you have the neutralizing antibodies, and it should be protective for you.
Now, it's interesting in reading that study, and bring up that neutralizing antibody graph again really quick so that I can understand. So the red line is my understanding is the high-dose group, is that right? And the blue line is the low-dose group. And when I think about what we've been hearing about this Moderna vaccine, the high-dose group had severe reactions, several hospitalizations. My understanding is they're thinking of scrapping the high-dose group going into the third phase of the trial. So when you look at this blue group, they are really slow to the kick. It says it's not until 2 weeks after the second vaccination do we start really seeing any production of neutralizing antibodies that would matter, and nowhere near what the high-dose group did. But it's certainly, you see a problem, and I think we see what you're talking about there. Now, did they see similar reactions in the human beings? I mean, did the humans did we get neutralizing antibodies in human beings in that part of the study?
Well, they didn't. Yeah, with the Moderna study, when they published the results, they gave us a chart where they showed the neutralizing antibody levels in the 3 different groups. So you have the low, the medium, and the high dose group there. So these are the neutralizing antibodies. Now we don't really know what the binding antibodies were because that's not part of this chart. But so if you look at the chart here, you know, you get the second vaccine at day 29. So the red box there is day 36. And you can see you don't get this big jump in neutralizing antibodies until you get that second dose. Now, do you get a big jump in binding antibodies? Probably. I mean, they do mention that pretty much 100% of people have antibodies by day 15. So you got to say, okay, what kind of antibodies are those? Are they talking about neutralizing antibodies, or do we get this big binding antibody response initially and then the neutralizing antibodies come on the tail end the way they did with the monkeys?
So the human beings, we're seeing the same issue with humans. We're getting virtually no production of neutralizing antibodies for over a month. So that means these people are walking around with that problem where their antibodies aren't going to line up. They're not going to grab the virus the right way, and they might actually help deliver it into the immune cell where it will become a factory, create a cytokine storm, and start proliferating throughout the body. So if you're looking at that as a doctor, you'd be thinking, am I correct, you don't want to come anywhere near this virus after your first vaccine for those first 4 weeks, or you could really be in trouble.
Right. I mean, you got to remember that this trial was 45 people. You know, it was 45 healthy 18 to 55-year-old, mainly white people. And so, you know, I don't know what would happen if they got exposed to the virus. You know, if they got exposed to the virus without being vaccinated, they'd probably be fine. But with the vaccine, what would happen? This is the whole problem with these vaccine trials. Until a person is actually exposed by the virus, you don't know. It's not like a monkey trial where, you know, we're going to intentionally expose somebody to the virus. I mean, that would be unethical. They don't do those kinds of trials, and so we will never know. It's a theoretical construct, but it's a very concerning theoretical construct given the history of this type of response with previous vaccines. And it's not just the SARS-1. I mean, this has happened with other types of vaccines. You know, they thought that previous vaccines with the flu virus vaccine may have actually worsened outcomes for people when they did get the H1N1. So it's not, you know, just something that's happening in isolation that we're, you know, sitting in our bedrooms late at night trying to figure out what possibly could go wrong with this vaccine. It's a very real construct. And the bottom line is we don't know, and this thing's being rushed into production, and they're going to, you know, they're going to be injecting this into 30, 40, 50,000 people. And we'll never know the outcomes until they actually have those kinds of, you know, how many of these people were exposed and what happened when they were exposed and how many of them became sick. And, you know, the ones that became sick, did they have comorbid problems? Were they elderly? You know, all these things that we need to know before you can unleash this kind of a vaccine on the whole population or the whole world.
You know, and one of the things that I found was disturbing, I want to get into this a little bit, is you know, when we think about we can't do or we're not doing challenge studies, we're not going to put these people in contact with the virus, at least not on purpose. We're only doing with animals. And then I saw these articles coming out of Nature magazine that we may be using the wrong animals to really get into this. Labs rush to study coronavirus in transgenic animals. Some are in short supply. That research, led by virologist Chao Shan at the Chinese Academy of Science Wuhan Institute of Virology, found that rhesus macaques, these are monkeys, infected with the coronavirus had a fairly mild illness. To find better models for more severe human infections, researchers will have to look at different animals and vary other experimental factors, such as the route by which the virus is administered, he adds. That's problematic, is it not? I mean, why are we using monkeys that don't really have a very severe reaction to this vaccine? It seems I mean, here's what I want to try and understand. I'm not a doctor, but it seems that as I grew up studying science in school and in high school, we talked about a theory. A scientist has a theory. And then they are supposed to challenge that theory. Or they build a drug, or they create a vaccine, or you even build a car and you have airbags. The entire purpose of the science is to see if you can make that car fail, if you can see that the dummies actually get hurt, or with a vaccine that you see that the vaccine fails. You want to be stressing it as hard as you can to make sure that it's safe. And look, after stressing it, putting every challenge you can think of against it, if it survives, we say, you know what? This will probably work for a lot of people. But when I look at these trials, it looks like they're doing anything but. They're trying to make the vaccine look good. And of course they are. It's only the manufacturers that are doing their own safety trials right now. But they're choosing a monkey, as this article is pointing out, that doesn't even have a severe reaction to this. It tends to be very mild. So how are we going to see that acute reaction that's really happening in about 0.26% of our population? That's the 0.26% that are dying. That's got us all locked down, destroying our lives, destroying the world, and now you're not even using the right animals to exhibit that pathology that could help us understand it. Am I missing something here?
No, not really. I mean, you've got problems with this virus in terms of finding a model. I mean, the monkey's probably the best. The mice, the only reason why a mouse can even get infected with SARS-CoV-1 or 2 is because we genetically altered them to make a human ACE2 receptor. So when they say transgenic mice, that's what they are. They've been altered so that they express the human receptor. But again, you do studies on young mice, you do studies on young monkeys. Even if they took the macaque monkeys and they were more like 20 years old, okay, that'd be more like maybe a 50 or 60-year-old human. Now maybe you have a better model. But again, if they're doing 3 to 6-year-old macaque monkeys, they're looking for a good outcome. They did 24 monkeys in that study, 12 girls and 12 boys, whatever they call them in monkey world, but that's all they did, 24, 3 to 6 years old. None of them even developed a fever. They had to do lavages and swabs to find the virus. They had to, they sacrificed a few of them and looked at tissue to find the virus. They weren't sick. The only thing that they noticed behavior-wise is they decreased what they ate and they lost a little weight. That's what they had. So if that's your model, how is that going to relate to somebody who's 60 years old and 50, 60 pounds overweight and type 2 diabetic and has heart disease? How is that going to be relevant at all? You're trying to make your experiment as likely to succeed as possible. And it's not just in this. I mean, this is what's happening with science. The purpose of an experiment should be to prove yourself wrong. If you cannot prove yourself wrong, then you must be right. That's really what science is based on. And this is the opposite. What can we do to make sure that nothing bad happens and we get a good outcome?
And we're talking about an issue that, as he pointed out, when we've had this issue with RSV vaccine, kids died. Dengue vax, which was distributed in the Philippines, over 100 children and people died from that vaccine from this exact problem. They had an overreactive immune system that just wiped them out when they came in contact with the virus. The vaccine didn't help them. It killed them. So we're talking about an issue that potentially, in the extreme forms, the vaccine could end up killing people, and yet we are letting these pharmaceutical companies take the easiest route, pick the perfect window for their success to show us and say, hey, look how great this is, while now we're seeing mandates in Australia and countries saying, as soon as this thing's available, we're going to take away your choice to opt out. You're going to have to get it. It's incredible. Now, there's something I'm confused about, though. We're just talking about antibody-dependent enhancement, but there's this other term, antibody immune enhancement. For a while, I thought it was the same thing until I read a couple of articles that I'll run by you, and Peter Hotez is getting in here. But first, this is from Proceedings of the National Academy of Sciences of the United States of America. It says, news feature, avoiding pitfalls in the pursuit of a COVID-19 vaccine. It says some researchers argue that although ADE has received, that's antibody-dependent enhancement, has received the most attention to date, a serious problem, we've all been looking at it, it is less likely than the other immune enhancement pathways to cause a dysregulated response to COVID-19. Given what is known about the epidemiology of the virus and its behavior in the human body, there is the potential for ADE, certainly, but the bigger problem is probably Th2 immunopathology, says Ralph Barrick, an epidemiologist and expert in coronaviruses. This is what you were talking about. Now, but there's a difference, right? You showed us antibody-dependent enhancement, where we have the little antibody, the Ys. I get it. If it docks, we really want those to be neutralizing antibodies. But what is this Th2 immunopathology? And perhaps if I get into Hotez's article, that might help me understand it. So let's go to that. This is Science Direct. The potential role of Th17 immune responses in coronavirus immunopathology and vaccine-induced immune enhancement. It says, new information has highlighted a critical role for host Th17 inflammatory responses in the pathogenesis of COVID-19 pneumonia and edema. This includes the release of key cytokines, including IL-17 and GM-CSF, and other elements of exacerbating viral immunopathogenesis through downregulating Treg cells, promoting neutrophil migration, but simultaneously inducing Th2 responses. Importantly, IL-17 can also induce pulmonary eosinophilic responses and allergic disease, in part by promoting eosinophil production from the bone marrow and recruitment and extravasation into the lungs. My God, I mean, what I feel like I'm looking at here is, yeah, we're looking at all these other problems, but there may even be a bigger dinosaur, Th17. I mean, from my perspective, it sounds like Peter Hotez is saying, hey, while you guys are playing with the velociraptors over here, I've been studying a Tyrannosaurus Rex that's in the middle of this vaccine. Can you sort of help me make sense of what is he talking about? We're not talking about antibody-dependent enhancement anymore. He's talking about Th2 immunopathology.
Well, yeah, I will explain it, but only if you promise that you will award all of your listeners a honorary master's degree in immunopathology, because we're really diving deep into this stuff. All right, so we're going to backpedal for a second.
We're going to try and geek out. We're going to try and act like we know what we're talking about, you know.
Right.
But,
yeah,
okay.
So the whole idea here is when you vaccinate or when you have an immune response to a virus, really what you're looking for is Th1. These are T lymphocytes that are helper cells. Th1 cells are the ones that call in your cytotoxic T cells, your killer cells. They just ramp everything up, kill the virus. All right. So Th2 cells are more involved with allergies and autoimmune disorders. They create antibodies, but they're not going to be as effective at destroying the virus or the target as the Th1 cells. So you always want that, either a really predominant Th1 response or maybe a balanced Th1, Th2 response. But what you don't want is just a Th2 response. Because when you have all this Th2 response, you're going to create problems. And one of them that he's talking about is calling in this Th17. So this is another type of helper cells. You have Th1, you have Th2, you have Th17, and you have Treg. So the Th17 cells are involved with autoimmunity. One of the things they do is they bring in what are called eosinophils. This is another type of white blood cell, and those eosinophils are what are involved with inflammation. Now you get these into the lungs and you get scarring, you get fibrosis. So there's models of fibrosis that show they're driven by Th17 cells. We also know that Th17 is involved with autoimmune disorders like rheumatoid arthritis. They're developing drugs against these types of receptors and interactions to treat rheumatoid based on this concept. And this is what we've been screaming from the hilltops for however long, 20 years. That when you vaccinate and you induce Th2 immunity in a susceptible kid, you're going to get a Th17 response and you're going to get autoimmunity. And then it's autoimmune to what? Well, in the case of autism, it's autoimmune encephalitis. It's autoimmune antibodies directed against the brain. So here we're talking about autoimmune antibodies that are autoimmune response, or not even the Th17 response, that is creating all these eosinophils, creating all this inflammation and causing damage. And that's what most of us are terrified about with this vaccine. What's it going to do to that susceptible person? You're going to give them a lifetime of an autoimmune disorder to treat a virus, or potentially treat a virus that has a death rate of, what, 0.26%, 0.3%, whoever's numbers, it's never over 1%. And especially for young, healthy people, it's essentially 0.0. I mean, you have to go a few decimal points over to get anything other than 0. That's what we're talking about here. You know, risk benefit. You've got to have a vaccine that is safe and effective, but particularly safe if you're treating a disease that just doesn't have a high mortality rate for the vast majority of people that you want to vaccinate.
So when we're talking about these immune enhancement issues, there's now, I think, 2 or 3 different ones they're all arguing about that can take you out. So take me through, what are the different enhancements they're looking at, just so that we can read up on them in the future?
Yeah. So first of all, you have the antibody-dependent enhancement. That's what we talked about with the little animation we had, right? Second is cell-mediated immune enhancement, and that's what we were just talking about with the Th1 versus the Th2, Th17 response. Right. The third one is actually complement. You know, that's another arm of the immune system, but you can get complement-induced immune enhancement as well. And it's the same thing. The complement will get that virus bound and get it enveloped in an immune cell where it makes a bunch of copies, produces a bunch of cytokines, and you get cytokine storm. So you have 3 different ways you can do this. But again, the ones we're most worried about are antibody, and really the one people like me are worried about is that cell-mediated immune enhancement, because that almost certainly is going to happen with elderly, with people with immunocompromise. The complement version is probably going to happen with people with type 2 diabetes and morbid obesity. They have high complement levels anyway.
All right, so now when I was reading all of this, it started making me think. I've been on a 5-year journey investigating the safety of vaccines. I have interviewed parents that have their understanding of what they saw before their own eyes. My child got a vaccine. They had brain swelling that night. They screamed for days. They started slurring their speech. They never got their speech back. They're in diapers and they're 18 years old. Or it was an autoimmune disease. My child, ended up having, diabetes shortly after a vaccine, or lupus, or all of these things. And I feel like Peter Hotez has said that all the anti-vaxxers need to be shut up, like they're crazy. And yet here, I feel like he is finally describing what all these parents have been talking about. You're enhancing the immune system, you're driving it into overdrive, but the wrong part of it for maybe just some of these kids, and now they're exhibiting all sorts of autoimmune problems. And what I find fascinating is it feels like he thinks he's just brand new in this world, right? I've now just discovered the fountain of youth. I understand IL-17 can cause a cytokine storm and Th2 immunopathology. And I have to imagine guys like you that have been treating these children with autism for 20 years and a lot of the work by J.B. Hanley writing about these articles. I've been seeing Th2 and IL-17 in these discussions, IL-6, for years going on, and you have Hotez saying it's impossible that any vaccine causes harm in children or causes autoimmune disease, but yet here's his book, Vaccines Did Not Cause Rachel's Autism. I have to wonder if he's questioning the thought behind that book now, because he is only brand new now recognizing a vaccine, right now it's the COVID-19 vaccine, can trigger an immunopathology that could lead to brain swelling, autism. Certainly he must be making that connection. And I guess if he has tunnel vision, he'll say, but it's only going to be the COVID-19 vaccine. Oh, wait, and the RSV vaccine. Oh, wait, and the dengue vaccine. But what is making them stop short of saying, well, how about the flu vaccine? Or how about these other vaccines we're given? Because it made me think about what we've been reporting on the military study of the flu vaccine that showed, looked at thousands of the military, influenza vaccination and respiratory virus interference among Department of Defense personnel during the 2017-2018 influenza season. It goes on to talk about the fact that, of those that got the vaccine, the flu vaccine, there was about, I think, a 38% increase in coronavirus amongst those who got the flu vaccine compared to those that did not. And so I'm wondering, is that potentially, they're calling it, I think when I was reporting on it, it's interference. They were describing it as interference. But is it possible that the flu vaccine, which we're now about, I think we're producing more than we ever have this year and telling people we don't have a COVID-19 vaccine, but you better get your flu. Is it possible that that flu vaccine, which underperforms almost every year between 10 and 50%, there you go, flu vaccine 10% effective, is it possible that that could be creating a Th2 response or an antibody-dependent enhancement? And is that why we were seeing the military get coronavirus? Oh, and let me bring up also the Japan study. The Japan study that looked at the flu vaccine, this was a true vax versus unvax study, increased risk of non-influenza respiratory virus infections associated with receipt of inactivated influenza vaccine. And what this found is TIV recipients had an increased risk of virologically confirmed non-influenza infections at a risk of 4.4 times. 4 times the amount of upper respiratory infections amongst those who got the flu shot compared to those that did not. That sounds to me like they're having some overreaction based on a weak vaccine or antibodies, maybe too many binding antibodies. Is it possible that Peter Hotez and maybe other scientists around the world are finally waking up to the cause of injury by all vaccines? even though they are, very focused right now on COVID-19?
I think they're all aware of the thought process, and it's also why many of them, Paul Offit being an example, are very, very vocal about not rushing this vaccine. I mean, they are all about, we have to do the safety trials, because they know if we vaccinate 300 million Americans and we have an adverse event rate of, let's say, 1%, that's 3-4 million people that have new autoimmune disorders that didn't have them before. So that would be a disaster to the whole vaccine program, especially when we have people like you who have been, pounding the pulpit here for months and months and months about this vaccine and how dangerous it potentially can be and how we had problems with these previous vaccines. I mean, back to your points about the flu vaccine. And remember, 4.4, that's 440% increased risk of an upper respiratory infection because you got a flu vaccine. It wasn't specifically coronavirus, but it was any upper respiratory virus. Whereas the military, they showed specifically 36% increased risk of developing a coronavirus. Again, not SARS, but a coronavirus. And so to say that you should get your flu vaccine to protect you against coronavirus, there's a huge disconnect between the data and what they're telling us. Now, will they come out of tunnel vision and say, oh, there could be a problem with all vaccines? Dream on, Del. Dream on. I don't think that's going to happen.
I'm going to make them, though. I'm never going to let it go. And that's what Paul Offit's worried about, right? Because once the world watches the failure of a COVID-19 vaccine, suddenly this, 11th testament that says vaccines are safe and effective suddenly disappears. Now they go, wait a minute, not all vaccines are safe and effective. In fact, I think it's why we're seeing the conversation. You'd be shocked how many scientists that have come onto this show that tell us up front and say, I'm coming on to talk about the math. I don't agree with the things you've said about vaccines. They're now reaching out and saying, watching the science and watching the amount of lies that are going on and seeing how this vaccine is being dealt with, I am now starting to join you in questioning how were the other vaccines handled. I don't think they're going to get away with this, Dr. New, and I think it's why Paul Offit and them are screaming their heads off. Stop. Get this out of the public eye, because the world is now finally questioning the safety, sure, of one vaccine, but we all know it's going to bleed into all the other vaccines because, by the way, COVID-19 right now, we finally have a saline placebo in the Moderna trial because I can press the FDA to do it, but there's no saline placebo groups that can, tell us anything about the 16 vaccines we're already using. So I think this is really fascinating. I think it's fascinating to watch Peter Hotez, just boldly saying, look how smart I am. Look at how I found how these vaccines could fail. And totally unaware that he is really destroying the very foundation upon which all the other vaccines thought they were standing. This is an incredible moment in science history.
Yeah, and you got to remember, one of the early vaccines where they had the antibody-dependent enhancement was actually an atypical measles vaccine long ago. So that was on the list of, when you read the list of vaccines that had caused this, that's on the list, along with RSV and the dengue vax and all those vaccines. You got to remember, we're using messenger RNA vaccine here. This is completely untested technology. This is something brand new. This is not your father's vaccine, right? This is something new. And once we let the genie out of the bottle, once we do this and we damage somebody's immune system, I mean, you can come and see somebody like me and I can try and help you out and improve the outcome and all that. But at the end of the day, we've caused the damage forever. It's not fixable. And you have to say, in medicine, it's always risk-benefit. You have to say, is the risk of this disease worth the potential risk of this vaccine? And from what I'm reading right now, I don't want to take it. And most of my patients don't want to take it. So maybe they're going to shove it down our throats, but it is very, very scary when you look at all this research and you look at the data and you look at how they're doctoring not doctoring, how they're weighting their trials to be successful. Right. And then you're going to say, what? Are you just going to give this to white, healthy,
them for
18 to 50-year-olds? I don't think so.
Right. We should be testing it harder. We should be trying to see the errors, not trying to hide from the errors. Dr. New, thank you for clarifying these things for us. This is what we do on the High Wire. Yeah, we geek out. We go a little deeper than you're ever going to see on CNN and MSNBC. But look, if that's what you want, the headlines are always there. They're going 24 hours a day. They'll tell you what you want to hear. Here we're trying to get to the truth. Dr. Newt, thank you so much for taking the time today.
Hey, thanks, Del. You keep doing what you're doing, man. We're all counting on you. Love your work.
All right, awesome. If you like that clip, then be sure to check out our live broadcast of The High Wire every Thursday morning at 11 a.m. Pacific Time. You can watch it on Facebook, iTunes, and Twitter. We'll see you there.